Okay, so today we're going to talk about Blackboard assignment number 5, which is really your Unit 1, Lesson 1 notes. So we are now starting into our unit of trig, and we're going to start kind of small and kind of review some right triangle trig that you probably had a couple years ago in geometry. So some of this may sound familiar, but it's used just to make sure that we're all on the same page as we move forward through Unit 1. So in front of you, you have Blackboard number 5. This is something that should be also in front of you. If not, pause this video and you can print out the PDF that was located with this YouTube video online. So Blackboard number 5, the first thing we're going to start off with is each of the 6 possible ratios of a three-sided right triangle is used to define a trigonometric function. So we're just now getting into this idea of what trig is and these trig functions. I know it sounds a little intimidating, but I promise you as we go through this unit, it's going to make a lot more sense as we start building on this concept of trig. So there's really 6 types of trig functions, and the first 3 I think are pretty familiar to you: sine, cosine, and tangent. The 3 are less probably familiar to you, but they are also, and we're going to talk about this in a little bit, related to the top 3 trig functions in some way, and we'll get to that in just a few. But the 3 main trig functions are sine, cosine, and tangent. And if you remember back from geometry, sine is abbreviated as SIN, cosine is abbreviated as COS, tangent is abbreviated as TAN, cosecant, CSC, secant is abbreviated as SEC, and cotangent is abbreviated as COT. So let's talk about what this right triangle definition is and what they really all stand for. So in this main box that I have on this front page, we're going to fill in as best as we can what these trig functions are and how they are related to a right triangle. So the first thing we're going to do is we're going to call theta, and that's going to be kind of like a oblong, like a 0 or an O with a little slash in it. And I'll just write this. It means theta. It's a Greek symbol. And we're going to use it to represent an acute angle inside a right triangle. And we're going to call that theta the angle in our bottom right corner of our right triangle on our paper. The 6 trig functions of theta are defined as follows. And I think you guys kind of remember back from geometry, this little word is called SOHCAHTOA. And the S, the C, and the T all have meanings: sine, cosine, and tangent. And the OH, AH, and OA are basically the sides of your right triangle and their relationships. Okay? So over on the right-hand side, I want to fill out a couple pieces of information that you will need to build on for these 6 right triangle, or these 6 trig functions. The first is in relationship to the angle you're talking about. So in this case, it's theta. We're going to locate or write the relationship to theta, all 3 of these sides. The first is opposite, which means really kind of across from. Opposite of theta is what we call our opposite side. I'm going to abbreviate it as OPP. That means opposite. The side that actually forms part of the angle of theta is called your adjacent side, and we're going to abbreviate it as ADJ. This is your adjacent side. And obviously your hypotenuse, which we'll abbreviate as HYP. It's always the side that is opposite of your 90 degrees of your right triangle. So these 3 sides in relationship to theta have meaning for our 6 trig functions. So going back to SOHCAHTOA, that should sound pretty familiar to you from a couple years ago. Sine, the O has meaning, the H has meaning, and what comes first represents what goes in the numerator. Okay? So sine is actually opposite over hypotenuse. So we'll write that as OPP over HYP. Cosine That relationship is CAH, so the A comes first, so it's always your adjacent side length over your hypotenuse. Your tangent of theta is always opposite over adjacent. And the relationship of our top 3 trig functions and the other 3 trig functions are the reciprocals. And reciprocals, as we talked about earlier in the week, is basically just flipping your numerator and denominator around. So cosecant is related to sine because cosecant is the reciprocal of sine, so it's actually the hypotenuse over your opposite side length. Secant is related to cosine. If you flip those two around, it's hypotenuse over your adjacent side. And of course, tangent is related to your cotangent if you flip these two around, and you get these guys. So your ratio of the second column is the reciprocals of the ratio in the first column. So another way that we can write this the second column, cosecant is really just 1 over sine. Secant is really just the reciprocal of cosine, so we can write that as 1 over cosine. And cotangent is just the reciprocal of tangent, 1 over tangent. This will come in handy down the road, but ultimately making sure that you understand the relationship between the 2 columns and how they're all related to the right triangle is the most important piece. SOHCAHTOA I know sounds semi-familiar. That's something that we're going to build on as we start talking about trig and the unit circle and why we even need to know trig. Why do we even need to understand it? How is it helpful in real life? So we'll talk about that obviously in some upcoming lessons. But right now we just want to make sure we're all on the same page for right triangle trig and understanding the right triangle and how it's related to the 6 trig functions. Moving on to the back side, we have example 1, and we're going to work on this together. In example 1, there's a couple pieces of information that is missing that I'm going to fill in with you. Everything else that you have in front of you is just kind of the structure, and we'll kind of fill in the pieces of the right triangle. So let's say, for example, we're going to put theta in the bottom right-hand corner. We're going to call, for example, our ABC. We're going to call this side, we'll call this B for right now. We're going to call this 6. Let's call this A, the side length A, and we'll call this side length 8. And let's say at this point this is all that we know, okay? So if this is all that we know, we want to find out what our 6 trig functions are, what those ratios are, if this is the right triangle that we're given, okay? So this is the right triangle that we're given. Let's just say we're trying to find out what our 6 ratios, our 6 trig ratios, what they are. So the first thing that we need to figure out, in order to know what our 6 trig functions are, we obviously have to know all 3 sides. And at this point, all we know is 2 of the 3 sides. So how do we find the missing side length, which in this case we know is the hypotenuse? So to figure that out, we obviously need to go back to our Pythagorean theorem, the right triangle. So we know that a squared plus b squared equals c squared will help us solve this equation for our missing side length. If we plug in what we know, let's call 8a. So if we get 8 squared plus, if we plug in b, we get 6 squared equals c squared. 8 squared is 64. 6 squared is 36. And c is what we're looking for, so we have c squared left over. If we add these two together, we get 100. And to solve for c, we actually have to square root both sides. So we get c is equal to the square root of 100. So c is obviously going to be 10. So we'll fill that in. From this point, we can now go back to sine, cosine, tangent, and then it's obvious reciprocals, and find out all 6 of these proportions and ratios. So starting out, before we can fill in this information, we have to address what our opposite side is, adjacent side, and hypotenuse. Hypotenuse is always the easiest to find. Opposite of theta is always across from, so you can draw an arrow to it inside, so we know this is going to be our opposite side. And our adjacent side is always going to help form part of that angle of theta. And now we can fill it in. Sine is opposite over hypotenuse. I'm going to write SOHCAHTOA, T-O-A, up at the top to kind of help me. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And if I go through and I just flip each of their reciprocals around, I end up with something similar to this. Now I just have to simply fill in the pieces of information that I know. So sine is opposite over hypotenuse, which in this case I know is going to be 6 over 10. And if I reduce that fraction, because they both have 2 that's in it, if I divide 2 out from the top, I get 3 over 5. I don't even have to do the work over here, because I just know that hypotenuse over opposite is just going to be 5 over 3. Adjacent over hypotenuse, I know is going to be adjacent, which is 8, over hypotenuse, which is 10. 2 goes into both of these numbers, so if I divide a 2 out, I get 4 over 5. So I can just flip those 2 around for my secant. And then if I look at tangent, opposite is obviously 6 over adjacent, which is 8. They both have 2 that I can divide out. 6 divided by 2 is 3. 8 divided by 2 is 4. So I get 3/4. If I flip these guys around here, I get 4/3 for cotangent. So that's my example 1. Another thing that I want to just kind of mention really quick is in example 1, it's going to be important that you know that the reciprocal of sine is cosecant, the reciprocal of secant is cosine, and cotangent is tangent. So you need to know that those are related with the reciprocals of each other. One way that I find it pretty easy to remember is that my sine starts with an S, which means its reciprocal is going to start with a C, okay? My cosine starts with a C, so I know that its reciprocal is going to be the S. So it may help just to kind of keep in your head, because it's really easy to link cosine and cosecant together, as well as sine and secant. Just remember when you're flipping them that you're actually going to be flipping the S and the C around. So the sine actually goes to cosecant, cosecant and secant, or cosine and secant are reciprocals, and it's pretty easy to remember that tangent and cotangent go together. Just a little tip that may help down the road. All right, so at this point, that kind of finishes up our notes for Blackboard assignment number 5. What I'm going to have you guys do now is work on the Now You Try and work on this problem, which is your another triangle where you're going to be dealing with your sine, cosine, tangent, and finding the reciprocal values as well. So a couple of things I'm going to point out here. This triangle, the example that I have in front of me, is actually a little bit different. This triangle is a little bit oblong. So I'm going to pretend for a minute. I'm going to write note on here. Pretend this is a 45, 45, 90 special right triangle. Okay? So I'm going to actually redraw the triangle I want you to use for this example to bring to class the next time we're all together. I'm going to have you redraw this with the side being 3, theta being here, and using what we talked about in Blackboard assignment 4, just this triangle the way it is, I want you to fill in the other 2 missing side lengths with our special right triangle, if you know this. And from there, I want you to fill in all the proportions for these 6 trig functions. And we'll talk about that the next time that we're all together in class.